Hey people, we're going to do a small derivative hack. Uh, another tool for your toolkit. Let's say that we are going to, our function is this. I'm going to make that a little bit thicker. Okay, so uh, here's our function. Y equals square root of 3 over x minus 1. And not overwhelmingly difficult to differentiate once you've got a little bit of practice. Uh, but so we're going to apply a what might be a new to you technique to this. Remember, what we're looking for is dy by dx. Okay, so what I'm going to do is I'm going to rewrite the function in terms of x. Okay, so we'll square both sides and we get y squared equals 3 over x minus 1. Now let's bring that 1 over to the other side. So now we've got y squared plus 1 equals 3 over x. And then now we're going to need to swap the x with the y squared plus 1. So we'll end up with x equals 3 over y squared plus 1. Okay, now what are we going to do with that? We're going to scroll up here and differentiate dx by dy. So just the inverse of what we would normally do, because why not? So let's see. Okay, so let's see here. Now, I wrote it down ahead of time. If that's u and that's v, then we want u prime v minus uv prime. And that's all over v squared. Okay, so what's v squared? Well, we'll just write that down as y squared plus 1 all squared. No need to work it all out just yet anyway. And then u prime, this is our u prime is just, u prime is going to be, it's a constant. So u prime is going to be 0. So who cares about the v? It's just going to be 0. So that's 0. So we have minus, and then now we just do uv prime. Okay. U is 3, and v prime is 2y. 2y. So what do we have? We've got negative 6y over y squared plus 1 all squared. Okay. But what do we want to do? We don't want dx by dy. We want dy by dx. But guess what? We just take the reciprocal, because we can do that. Somebody may wrap my knuckles for calling it taking the reciprocal, but essentially it's the same process. We're just going to flip that. So that equals minus y squared plus 1 squared all over 6y. But we got to remember, I mean, while this is the derivative of y with respect to x, we want to express our function in terms of x. So we have to remember, what is y? Well, y was, I'll rewrite it up here, y equals square root of 3 over x minus 1. That was just our original function. So now we're going to do some substitution. Okay, so we got minus here, 6y. We'll write that down as 6 times square root of 3 over x minus 1. And then up here, we've got y squared. Well, that's all this squared. So we got 3x minus 1. That's the y squared. And then plus 1, plus 1. Okay, and that's all squared. Okay, well, the beautiful thing about that is, I mean, these cancel out nicely. And so we end up with minus 3 squared over x squared all over 6. There's our y, just be writing the same thing. And now we're going to simplify that. So what do we do? Let's bring this x squared downstairs. So that equals, well, we'll put the 9, 3 squared is 9. So got 9 up here. 6x squared times the square root of 3. You see how little of this is actually calculus, and most of it is just algebra or pre-calculus. And then now we want to divide by 3, divide by 3. So simplify that. 2x squared 3 over x minus 1. And that is a Bob's your uncle. That's your dy by dx. Now, what I would recommend to you is try this derivative using another technique, using maybe a more standard technique. This is what you're differentiating, and you want to use the chain rule. Try that out and see how that compares to what we ended up here, down here at the bottom. And that's all she wrote. That's it. Greetings, greetings. Greetings from Switzerland. I remember you, Christopher, Christoph. I'm saying an R that's not there. Christoph, I remember you from a couple of streams ago, or last stream, I guess. So thanks for finding me, and thanks for coming back. And I'm going to be putting this up so that you can watch it again in the replay. And until next time, Bob's your uncle, and cheers.